Welcome to the course Business Analytics and Data Mining Modeling using R. So, previous lecture we talked about visualization techniques. So, we will continue our discussion from the same point where we left in that lecture. So, we were discussing bar plots, and we were in this code. We had imported this particular data set used car. So, this has already been imported in data frame 1, and we were also able to create this particular new variable age. So, this has been created using the manufacturing year variable that was available in the data set. Then it was appended to the data frame, and then we had eliminated some of the variables which were not useful for our purpose. So, after that we were left with this particular data frame. So, now we have 9 variables. You can see fuel type, then showroom price, kilometers and price, transmission, owners, airbags, C price and age. So, then another command, another useful function that is available in R is str. So, we have discussed this particular function before as well. So, this actually help us understanding the structure of the data set, different variables. So, you can see a fuel price, this is factor variable, and with 3 levels being CNG, diesel and petrol. Another important point that I would like to highlight here is the factor variable or categorical variable that are created in R. The labels would be in the alphabetical order. So, therefore, you would see that CNG has been displayed first. So, this has an impact on many functions that are available in R, wherein the CNG is taken as the default category. When we will start one of the formal analysis, let us say regression, then we will come across some of these important peculiarities in R and different R function, specifically with respect to factors. Now, other variables you can see that showroom price, kilometer, price, transmission, owners, airbag, all have been displayed as numerical variable. But if you really look at the variable transmission and C price, so they are actually categorical in nature, because the transmission can have only 2 values, that is 0 and 1 for automatic and manual. So, this is important. So, therefore, we need to convert this numeric variable into a factor variable. Similarly, C price that has been created by us manually, as discussed in the previous lecture, where 1 was assigned for price more than 4 lakhs, equal to or more than 4 lakhs, and for the cars having price as less than 4 lakh were assigned 0. So, therefore, only 2 values are possible, 0 and 1. So, this variable also being categorical or factor variable. Therefore, we need to convert C price variable as well into factor variable. So, let us do that, do this. So, as we have talked in supplementary lectures, as dot factor is the command that can be used to coerce a numeric variable into factor variable or categorical variable. So, let us execute this particular line. So, first transmission. So, we run this line, and then let us also run C price. So, these 2 variables have been converted into factor variable. Let us look at the structure command, structure function again. Now, you would see in the transmission, you would see factor with 2 labels 0 and 1, they have been created. So, the variable has been converted into a factor variable. You would also see that C price has also been converted into a factor variable with 2 labels 0 and 1. So, with this most of the variables in our imported data set used cars, most of the variables they are being presented in, they are being stored in their suitable variable type. So, now let us look at the summary results. So, in the summary results you can find out that that the categorical variable, for example, fuel type, you can see counts have been displayed for different categories. For example, there are only 3 records having CNG as fuel type, 52 records or observation having diesel as fuel price, and 24 records having petrol as the fuel type. Similarly, you can look at the transmission. 63 records having transmission 0, that is manual, and 16 records having transmission as automatic, that is 1, represented by 1. Similarly, C price variable, that also now being a factor variable or categorical variable. 0, there are 48 cars which are actually having a price value less than 4 lakhs rupees, and 31 used cars are there which are having price value more than, equal to, or more than 4 lakhs rupees. So, other variables are numerical in nature, therefore, many descriptive statistics have been displayed, for example, mean, median, max, that we already understand. So, let us move to some of the basic plots. So, two basic plots that we want to cover, that bar chart and scatter plot. So, let us first start with the scatter plot. So, let us go back to our slides and let us understand some of the key things about scatter plots. So, generally scatter plots, they are mainly useful for prediction tasks. So, the focus when we say that prediction task and how scatter plot could be useful with respect to prediction task, focus is on finding meaningful relationship between numerical variables. So, a scatter plot is mainly for numerical variable, both the axis they are used for numerical variable, both x axis and y axis, and for prediction task focus being identifying some meaningful relationship from the plot. Now, for unsupervised learning tasks such as clustering, focus is on finding information overlap. So, why this is useful, that when we come into our unsupervised learning lectures and start our discussion on clustering, we will learn more about this, but focus being finding information overlap between different variables for unsupervised learning tasks, and scatter plot can be useful in that. Now, both the axes as said are used for numeric variables. In the bar charts, x axis is used for categorical variable. So, this is reserved for categorical variable, and different groups, because this being a categorical variable, the variable on x axis being categorical variable, we can create different groups. So, there are going to be different categories, and they can be different groups can be there, and statistics can be displayed on y axis, and that can help us understanding the differences between groups and compare them. So, let us go back to RStudio and let us start with scatter plot. So, first plot that we are going to generate is between kilometer, km and price. So, before plotting, because we need to specify limits on x axis and y axis, so that our plot looks much clear, and we get more clear picture on the data. So, let us first understand the range of these variables. So, these range values of these variable kilometer and price is going to help us in determining the limits. So, you can see in the plot function, you would see that for kilometer the range is between 19 and 167, and you can see the x limits that I have specified there is 18 and 180. So, all the values are going to lie within this particular range. Similarly, on the y axis, the y limit that I have specified is 1 and 75, and you can look at the price values. So, they are 1.15 and 72. So, therefore, these values are also going to be lie within this range. So, x axis is kilometer is on the x axis and price is on the y axis. You would, as discussed before, price is the outcome variable of interest in this particular data set, and therefore, price is being displayed on y axis. Labels for x axis and y axis have been given appropriately using x lab and y lab arguments. So, we can run this particular code and you would see a graph has been depicted. Now, if we zoom into this particular graph, you would see that there is one extreme outlier there. This particular value, kilometers accumulated, they are far less, less than 25,000 kilometers, but you would see that price that is offered, it is much higher. So, it is more than 70 in this case. So, the price is much higher, more than 70 lakhs, that is. So, but if you look at the other values, so the majority of values are lying within 0 to 20 lakhs range, but this is the only outlier. So, from this we can understand that most of the used cars that are there in the data set, they are in a smaller range. Therefore, it would not be appropriate for us to study this extreme outlier along with these points. So, so we have to restrict our analysis to this range as well. So, it would be so we can eliminate this particular point and focus on these major chunk of points mainly lying between 0 to 20 in terms of price. You would also see that in this plot some of the points which are lying closer to x axis, but far away from the 0 value and the majority of the values. So, they have more kilometers accumulated, but price offered for them is also in the same range between 0 to 20. So, let us go back, and here you would see first we are trying to identify that particular outlier point. You would see I have given this price value greater than 70. You would see in the graph that this looks more than 70, price looks more than 70 lakhs. So, therefore, let us run this particular code. So, you would see this is point number 23. So, this is observation number 23 having fuel type at diesel and showroom price at 116 lakhs, and then you would see that showroom price is 116 lakhs and the offered price is 72. So, these are high numbers in comparison to the majority of other observations. So, we can get rid of this particular observation because this seems to be this can be considered a very distinct group. So, let us take a backup of previous data frame and now eliminate this particular point. Now, this is how we can eliminate this point. In the data frame, we can use these brackets, and the point number that index we can specify as -23. Minus will give this instruction that this point is to be removed from the data frame, and the data frame would be again stored in the same. So, let us execute this. Now, this particular data frame is gone. Now, let us again have a look at the range values, max and min values for both these variables, kilometer and price, and let us again replot the graphic. So, you would see that kilometers there is not much change, price, then here you would see some change. For example, earlier values were ranging from 1.15 to 72. Now, this is ranging from 1.15 to 13.55. So, even less than 15. So, the price is now less than 15 lakhs. Now, for kilometers also now this new range is 27.5 to 167, earlier range was 19. So, you would see that kilometers range has also increased especially for the minimum value. Now, let us plot this. Now, the x limit and y limit values have been appropriately changed, modified. You would see 18, 180 and 1 and 15 now instead of 75 earlier case. Now, let us plot this. Now, this is the new plot that we have. Now, you would see that the graphic is covering most of the points in a clear fashion. So, most of the points are covered in the graphic. Now, if we try to understand some of the relationship between these two numerical variable kilometer and price, you would see not much change. We can have a constant line that is going somewhere at price value of 4 lakhs, and it can be a constant line. So, it seems from this particular data points, if we fit this particular these data points into a linear model, then we would see that kilometers is not an important factor. So, the price is being offered irrespective of the kilometer. So, that is the kind of sense that we get from the data. So, this data can be described by a horizontal line. So, therefore, kilometer is not such a crucial variable in our analysis, specifically focusing on prediction tasks related to price. So, these are some of the insights that we can get from these basic plots. For example, relationship between price and kilometers, we can see that kilometers km might not be such a useful indicator for offered price, especially this is what we get from this, this is what we gather from this particular data set. Now, let us move to next basic chart, that is bar chart. So, we see the bar chart we want to plot between price and transmission. So, transmission is the factor variable that we have already created, and we can compute average price for different groups. So, we can create two groups based on transmission values. So, one is 0, that is manual, and the another transmission value could be 1, that is for automatic. So, these two groups, manual and automatic, and average price value for these two groups we can compute using this particular line of code. You can see I am trying to compute mean from the values. So, which is another function which can return more information on which you can find from the help section, but to give you a sense of this particular function which can find out the indices of the observations where transmission value is equal to 0. So, those indices would be returned, and then the those particular observation would be retrieved or selected, or subset would be created for us to pass to the mean function and to calculate mean of that. And mean is again dollar notation indicating that mean is to be computed only for one variable, that is price. Similarly, for another group the same thing can be performed. So, let us compute average price. You would see that average price numerical variable has been created, and there are just two values, these values corresponding to two different groups, group 0 that is for manual and group 1 that is for automatic car. So, these two mean values have been computed. Now, another variable that we want to create before generating bar plot, trans is the name of the variable. So, this is just for the labeling purpose. So, the transmission the labels that we are going to use in our plot, so 0 and 1 that are the names of the labels for two different groups. We could have used manual and automatic as well here. So, those could have also been the label names for our bar plot. Let us go with 0 and 1 right now. Now, because the this particular bar plot is between average price, the variable we have just created, and then trans. So, let us look at the range. Range is between 3.74 to 5.48. Now, if you look at the bar plot function that I have written here, the y limit is between 0 and 6. So, this particular range would be covered in this. So, average price is the first variable. So, this will go into the y axis, and the names dot arg here, this will go into the x axis, and the labels for x axis that we have just created using transmission. X lab name is transmission, and y lab y axis label is average price. So, let us execute this line, and this particular bar plot has been created. You can see this. For a group 0, that is the cars, used cars, manual with manual transmission, you can see their average price is somewhere between 3.5 and 4. And for group 1, that is the used cars with automatic transmission, their average price is ranging somewhere between 5 and 5.5. So, this kind of information. So, it seems that the cars, automatic cars with automatic transmission, they seem to be carrying more value. Now, let us create another bar plot. So, this time we are going to use only the one variable. So, this previous plot that we created, so we had one numerical variable on y axis and one categorical variable on x axis. Now, let us just focus on one variable, and that has to be categorical. So, it is going to be on x axis again. So, this variable is again transmission. So, what we are trying to find out is the number of cars which are manual and the number of cars which are automatic, the percentage. So, percentage of all records that we want to find out which are manual and which are how many are manual and how many are automatic. So, this is the code that we can actually use to compute this. So, you can see length. So, I am trying to find out the length of a vector which is going to be determined by this which command. So, which command is going to return the indices for transmission where it is 0. So, all those indices they would be counted using the length function and we will get the number of records, and you would see this has been divided by all records in the vector transmission that can be computed using the length function and passing on the argument transmission. So, this would be the ratio and then multiplied by 100. So, this will create a percentage value. Similarly, for group 1, that is for automatic cars, we can do this. So, let us execute this line. You can see a variable P all has been created and there are two values 80.8. So, 80.8 percentage of records they actually belong to group 0, that is manual, and 19.2 records they belong to group 1, that is for automatic cars. So, let us generate a bar plot. You can see P all is the variable and the arguments trans and limit. Now, in this case is 0 to 100 because we are using a percentage. So, that is the range, standard range. So, let us create this plot. You can see the plot. Let us zoom in. So, you can see x axis transmission, two groups 0 and 1, and then on y axis percentage of all records, and you can see 0, this is close to 80, and you can see 1 group 1 which is closer to 20. So, this kind of using one categorical variable, that is mainly a transmission, we can also create these kind of plots. So, this again in a way helps us in understanding the structure of the data. From this we can understand that majority of the cars, more than the majority mark, it is around 80%, most of the cars they are manual, and only 20% of the cars, if smaller number of cars, smaller percentage of cars are actually automatic. So, therefore, this gives us a idea about this particular structure. For example, if it were less than 5%, that then in that case it could be defined as a rare category, rare class, the automatic. So, therefore, this might have affected our formal analysis. So, these are kind of graphics can actually help us understanding some of the insights about the data and help us later on in formal analysis. Now, let us go back to our slides. Let us discuss next set of plots. So, next set of plots are actually distribution plots. So, mainly two distribution plots that we are going to cover in this lecture, in this course, mainly two, being first one is histogram, the second one being box plot. So, as the name suggests, these are distribution plots and help us understand the distribution of data. So, because this is distribution, so generally they are applicable to numerical variable. So, we are interested we might be interested in understanding the distribution of a numerical variable. This could be various reasons for various reasons that we will keep on learning as we go along. Once we understand the distribution of data, we can understand, we can verify some of the assumptions that are there, mainly in statistical techniques. So, distribution can help us, for example, understanding whether the data is following normal distribution or not. So, therefore, if it is not following normal distribution, what can be done? So, some of these plots are going to help us in that fashion. So, sometimes we might be required to transform those variables so that we are able to achieve the normal distribution. Sometimes if we want to convert a numeric variable into a categorical variable, so histogram and box plot, the entire distribution that they display, that can help us in terms of binning of those variables, how the bins or groups are to be created. So, those insights again help us in creating new variables. So, as shown in this slide, histogram and box plot, they are about distribution of a numerical variable. We get directions for new variable derivation as we discussed, and we also get directions for binning of a numerical variable. Now, useful in supervised learning, specifically in prediction tasks, because they are mainly applicable for numerical variable, and therefore prediction task being the important type for these kind of plots where we can actually get some help. For example, variable transformation is in case of a skewed distribution. So, we will learn more about the skew in coming lectures as well, and in this lecture as well. So, there could be a right skewed distribution or left skewed distribution. So, what are the transformation that can be done to achieve to actually reduce some of the skewness of the plot of the data. So, so that can actually be find out, that can be actually be shown in using histogram and box plot. Selection of appropriate data mining method. For example, if the data set is not able to follow, not able to meet some of the assumptions in a statistical technique, then probably we cannot apply them, and probably we have to go with some of the data driven techniques, some of the data mining technique, because there some of these assumptions are relaxed, and those techniques can always be applied. So, selection of appropriate method or technique can also be done using these plots. Now, further discussion on box plot. So, box plots they display entire distribution. So, till now, for example, whatever bar charts that we plotted, they were focused on one or two groups or categories that were there in the categorical variable, and the numerical values for the same were reflected in the y axis. So, that kind of information that we could get from the bar plot, but in the box plot we get the whole entire distribution, the whole range of values are covered. So, therefore, we can have a better look on the whole data, the full data. Now, there is another thing that can be done, side by side box plot. So, we can create side by side box plot that can again help us in comparing and understanding the difference between groups. Something that we did using bar plots, that can also be done using box plot, and in a much better fashion. So, this could be useful in classification tasks where we can understand the importance of numerical predictors. So, in classification task we are using some numerical predictors. So, these side by side box plot can actually help us in finding out how these numerical variables, numerical predictors can be best utilized, and their importance as well. Another usage of box plot could be in the time series kind of analysis, where we can have series of box plot, and we can look at changes in distribution over time. So, that can also be done. So, let us open our studio, and we will go through examples for box plot and histogram. So, let us also cover histogram as well before we go into so we will go through examples together for both of these kind of plots. So, histograms they generally display frequencies covering all the values. So, in the bar plots only few values are actually covered. So, in this case histograms we cover all the values, and vertical bars are used. More we will learn through our studio. So, again we are going to use the same data, used cost data. So, you can see that hist is the function that can be used to plot a histogram. You can see, because we are interested in this particular variable price, that is our outcome variable, and so let us see the range. So, range is same as we saw earlier, 1.15 to 13.55. So, let us so you can see that a limit minus 5 to 20 has been used. Why this slightly wider limit, we will see after the plot is created. And y limit, this is actually the frequency for different bins. So, we will see once the plot is created. So let us execute this line. You can see the plot. So in this plot, as you can see that for better visibility of this histogram, we have given this range from -5, and this particular is also and on this x-axis, on this extreme, right extreme also some more range has been given, so that we are able to visualize the whole histogram in one go in a much better fashion. So therefore, that is why this wider x limits were given, and you can see the frequencies for different bins over there. So this particular distribution, because this histogram covers all the values of a numerical variable, we can get a sense whether this whether a particular distribution is following is normal distribution or not. So in this case we can see that this seems to be a right skewed distribution, right. There is a slightly longish tail on the right side. So this particular distribution doesn't seem to follow normal distribution. Therefore, it is going to be slightly difficult to apply some of the statistical technique, for example linear regression, etc. So therefore, we would be required to do a bit transformation to make it slightly more of a normal distribution. Now let us move to the box plot. So again in the box plot, we are interested in these two variables, price and transmission. So let us look at the range, which is again is going to be the same, and box plot is the function that is used. So in this case this is price versus transmission. Transmission is going to be on x-axis and price is going to be on y-axis. So different groups different categories in transmission would be displayed on x-axis, and for each of those groups price distribution would be displayed, price values will be displayed on the y-axis. Limit for y-axis, as you can see, 0 to 15, and the labeling is also you can understand. So this is the box plot. Let us have a look. So in the box plot, you would see that 75%, almost 50% of the values they are in the they are generally remain in the box, and this black this line, this particular line, this is actually the median value, and this is the starting point of the values, and then you have in the box, then you have first quartile, and this one is third quartile. So all the values in the box are between first quartile and third quartile. So therefore covering 50% of the values, median is displayed, and the majority of the values are in this range between these two limits, and some of the values that are displayed using squares, they can be called outliers. Similarly, this was for group 0, and for group 1 also again the same thing. This line, this particular line is median, then you have first quartile and third quartile, and creating the box, and other things remain same, this value being the outlier. Now you can see between group 0 and group 1, the median value, you can see this is much lower from group 1, median price value is much lower. So the whole box plot for group 1 is much higher than the box plot for group 0. So there can be a clear separation between these two groups can be seen over there. If you want to look at the mean value for those two groups, that can also be done. So we will have to compute the means for those two groups. So this can be done using the by command that is available in R. So first is the first argument is the variable for which we have to generate the mean, and the second argument is the categorical variable, the groups for which we have to create the mean and the mean function. So let us execute this code. So means would be created, and once means have been created, we can plot them using the points command. So points is the command which can again be used to plot the points on a particular graph. So in this case, PCH is the plotting character. So, in this case plotting character as defined by value 3 is going to be displayed in the plot, which is nothing but plus sign. So, let us execute this line. More information on points command you can find out from the help section. So, you can see plus sign visible there. Let us look at the this plot. You can see plus sign exactly lying on the median value, very close, exactly matching or very close to median value for group 0, and you can see for group 1 plus sign is much higher than the median value. So, the skewness that we saw earlier, maybe that is coming because of the group 1, that is automatic cars. So, let us stop here and we will create, we will continue from here. In the next lecture we will create few more box plot and we will go into basic charts and these distribution plots, they are mainly 2D graphics. We will go in more into multivariate or multidimensional graphics in the next lecture. Thank you.